Hello, this is the Algebra 1 Semester 2 review. This is the first half, even though I'm uploading it after the second half, so I'm starting with number 1 up top, which asks if the square root of 37 is rational or irrational, and it's going to be irrational. If we put it into a calculator, we will get just over 6. Or 6.0827 and so on, but it won't form a pattern that repeats, and it won't terminate, so this would keep going forever. So that's an irrational number. And real quick, our perfect squares, right? If they ask you if the square root is a rational or irrational number, usually you'll get 1, 4, 9, 16, 25, 36, 49, 64, 81, right? Those are our perfect squares up to 100. So the square root of any of these would be rational. So the square root of 36, or 6, is rational. But the square root of 37 is irrational. Okay, number 2 says -3 to the -4th power. So first let's make that into a positive exponent. So this is equal to 1 over -3 to the 4th power. And a positive or negative number raised to an even power is going to be positive. So this is 1 over 81. I know this is exam week coming up, so cutting it kind of close, but all right. 3 says 4 to the -1 times 6 to the 0. Okay, so 4 to the -1 is 1 over 4 to the 1. And any non-zero number to 0 power is 1. 4 to the 1th is just 4. Times 1 is still 1/4. Number 4 says -4x cubed, or the opposite of 4x cubed, times 2y to the -2 times 5y to the 5th times x to the -8th. Okay, so what I can do is either rearrange these to do the multiplication, say x's times x's, or I can change my negative exponents into positive. What I'm going to do is, first I'm going to do the constants. So that's -4 times 2, or -8 times 5 is -40. And then I'm going to say x cubed. I don't want to make that look like I'm raising it to a power. I'm just going to take x cubed and x to the -8, and when I multiply two powers with the same base, I'm going to add my exponents. So that's 3 plus -8, 3 minus 8, or -5. So that's x -5. And then y to the -2 times y to the 5th is y to the -2 plus 5, which is y cubed. And then I will put this I'll change this into a positive by putting it in the denominator. So I will get -40 y cubed over x 5. And if you want, you can check your answers by picking a number for x, like 2, and picking a number for y, maybe 3, and putting it into your original and then into your answer, which will tell you if you have equivalent expressions. It won't necessarily tell you if you have written it in simplest form, but at least it tells you you're on the right track. Let me just spot check this. -8, 5, -40, 3, -5, negative, okay, looks right. 5 says 3xy cubed all squared times xy to the 6th. Okay. So if I want to raise a power to a power, everything in this quantity is going to be squared. So that's 3 squared times x squared times y cubed all squared, and that's times the product xy to the 6th is x to the 6th times y to the 6th. 3 squared is 9. I'll rewrite x squared for now. Is this still showing up? Yeah. So when I raise a power to a power, I multiply my exponent. So that's y cubed all squared is y to the 3 times 2, or y to the 6th. And that's still times x6, y6th. So that's equal to 9. X squared times x to the 6th is x to the 2 plus 6, or x to the 8th. Y to the 6th times y to the 6th is y to the 6 plus 6, or y to the 12th. It's through 5. Any questions? Go ahead and you can post them. Ask me. I'll try to get back as soon as I can. Six. That's right at the top. We're trying to focus here. Does it want to go? Is g to the negative 12 h cubed over g to the negative 15 h9. So let's do the division. So this is g to the negative 12 divided by g to the negative 15 is g to the negative 12 minus negative 15. So it's negative 12 plus 15, which is 3. And then h cubed divided by h to the 9th is h to the 3 minus 9. So 3 minus 9 is negative 6. And I'll just rewrite that with positive exponents. Right, so h to the negative 6th is 1 over h to the positive 6th. Make sure I copied that down right. Q, okay. Number 7 is the quantity 5/9 all cubed. Which is 5 cubed over 9 cubed, which is, oh, I used my blue, 5 times 5 times 5, and 9 times 9 times 9. So 125 over 729, which is about, well, that's probably the form they want. 0.171467. Clear that out. All right. So 8. This is the quantity 2 minus the square root of 5 times the quantity 2 plus the square root of 5. Yeah. Okay, so we FOIL this out, and what happens is when you have the conjugate pair, like a minus b and a plus b, the middle terms are going to cancel. So first times first, 2 times 2 is 4. So outside is 2 times the square root of 5. It's plus 2 root 5. So the inside will be the opposite of root 5 times 2, or minus 2 root 5. And then this will be minus the square root of 5 times the square root of 5, which is 5. So these will cancel. And I'm just left with 4 minus 5, or negative 1. And this comes from, if I have a plus b times a minus b, that's equal to a squared minus b squared. So in our case, a is equal to 2, b is equal to the square root of 5. So you don't have to remember the formula. You can just FOIL it out, and but the middle term should always cancel if the only difference is positive and negative. A plus b times a minus b. That was 8. Okay. Number 9. That's on there, great. X squared all to the 8th. X squared all raised to the 8th power. So that's x to the 2 times 8. Right, raise a power to a power and multiply my exponents. So that's x to the 16th. A6 over a to the 6th power divided by a to the 7th power. So this is our quotient rule. So I subtract my exponents. So that's a to the 6 minus 7, which is a to the negative 1, which normally you're going to want to write without negative exponents if you can help it. So that's 1 over a to the 1, or 1 over a. Because x to the negative a is 1 over x to the positive a. Determine whether the sequence is arithmetic or geometric. 8, 24, 72, 216. So an arithmetic sequence, I'm adding the same number each time. I have an initial value, and then I'd be adding the same number. If it's decreasing, I could be adding a negative, right? So this one though is geometric because I'm multiplying each time. So I do 24 divided by 8, which is 3. So each time I'm multiplying by 3. 24 times 3 or 72. 72 times 3 to 216. So that's geometric. They didn't ask you, but the ratio is equal to 3. So, and then our next term would be 216 times 3, 648. But this just asks to determine if it's arithmetic or geometric, and this is geometric. Because I'm multiplying, I have initial value 8, and then my ratio is 3, so I'm multiplying each time to get my next value. Okay. It says write the polynomial in standard form, then name it based on its degree and number of terms. So as written is 2 minus 11 x squared minus 8x plus 6x squared. So first I'm going to combine. So this is negative 11x squared plus 6x squared is negative 5x squared. Do that in another color. And then these don't combine, so I'll just write them in descending order. Minus 8x plus 2. So to say standard, yeah, so standard form is descending order, so I'm looking at the powers of the exponents. So here it's this, I only have x, my only variable, so that has powers too. So we're not looking at the largest sort of coefficient, we're looking at the largest power. So 2, 1, 0. So that's standard form, and this is a quadratic trinomial. Quadratic because my highest power is 2, x squared. trinomial because I have 3 terms, right? Even though it sort of looks like we may have 4, I can combine those. So once it's in standard form, it's only 3 terms. Right? So monomials for 1 term, binomial 2 terms, trinomial 3 terms, and then you'll just say 4 terms, 5 terms if it goes more than that. And then your powers are, there's your constant 2 within this quadratic trinomial. It will be linear if the highest power is 1, quadratic for 2, cubic for 3. Someone will say quartic for 4, and then normally you just say, you know, 5th power, 6th power after that. Can I do this one? I'm going to clear the board. So this one is like a perimeter of a triangle. Okay, but the triangle looks, well, it's like a, it looks kind of isosceles, but it says not to scale. So really they've given me 3, is this 13? Yeah. Write the perimeter of the figure. Figure is a triangle. Well, I'll just draw what they've done. 3x plus 2, 6x, and 5x. Really all they want you to do is add these 3. So 3x plus 2 plus 6x plus 5x. 3x plus 6x is 9x plus 5x is 14x plus 2. And I don't know what x is, so I don't know what, and we don't have units, so I don't know, you can't say what the perimeter is as far as a number because we don't know what x is. It's 9, 14, yeah, but they want 14x plus 2. Just to know that to do the perimeter. Sometimes you'll get algebraic expressions for side lengths in a, you know, geometric figure like a triangle or a square or whatever. Sometimes you'll have to set them equal to each other, but again, this is not to scale, so you're just adding it. So 14 says simplify the difference, so I have a quantity